Okay. This is the computation of the loadings, no? I should have show you the building. But I think ma-follow raman siya siguro. So we have here the dead loads. Then actually ma-follow raman siya. Then I posted this one in your Google Classroom. You can follow this one because there are already formulas, no? Like this one for the beam and column self weight. The unit weight of the concrete is 23.6 kilonewton per cubic meter, no? Then to compute for the slab, to get the pressure, dead load, no? Say for example, 120 millimeter thick. So that is 3.6 times 0.12. This KPA. Then floor finish, which is 40 millimeter thick. Again, times din mo siya sa unit weight of the concrete. Then the glass, because the building is made of glass, di na lang nako i-show, no? But ma-imagine guro ninyo. So, this is actually from NECP dead load 2010 or 2015 kay pareha raman siya loading. Wala man na outro actually. Sa 2000 from 2010 2015 ang grabe og changes update sa kuan. I mean, load is ang wind load. Grabe na ay then sa seismic naapoy changes. But again, no, we will adapt the NECP 2010 computation and provision. But for the, yes, actually pareha raman jud halos sa the dead load, live load sa NECP 2010-2015, pareha raman siya. And some other factors also pareha ra sa ang 2010 o 2015. Then to get the dead load of the glass is ma-follow ragid siya. Because the glass, I mean the height of the glass is 3.5, no? Ma-show ba nako? Marag ma-show nako na to ang building ha. Ano ibutang? Sample building. I think this one. This one. Yes. This one. This is alright. Atong tulungan. Okay. Let's add again sa lecture. Okay. This is the floor plan, but the building is this one, no? This made of glass, gid siya. Irish mauni ang model building nato. Any comment or suggestion para madugang? You can also suggest structural framing system from Sir Aquino. And this one, this is the building, no? And so mo to siya, made of glass, which is 6 millimeter. So kung yung tinawag sa NECP, the unit weight dead load is kilonewton per cubic meter. Then you compute the kilonewton per meter, which is gas around siya sa like almost perimeter of the building. Mostly is glass. Then CHB walls, 2 faces plastered. Then 150mm CHB exterior walls. This is for exterior. So this is from the table, no, in the INISIP 2015. Then sa INISIP 2015, the masonry is hollow concrete masonry units unplastered. You have to add 0.24 kPa for each face plastered. So, katong ganina, the unit weight of sa HB is 19.6 kilonewton per cubic meter. The unit weight nga akong gikuan is, I think, that is 2.82 for 150mm thick. Naman tayo klase-klase nga si HB. We have 6 inches and 4 inches thick CHB. So, this 150 this is 6 inches. So, manang full grout, with full grout, you will have unit weight of 2.82, no? Then, plus 0.24. Actually, this is KPA na ni siya. For each face plastered, manang plus 0. Ano man to ganina? 2.82, then plus 0.24 times 2 for each face plastered. Then, for this 100mm thick CHB sa interior walls, the unit weight, this is also from the table, CP 2.69 kPa, dayon. This value plus, I think this is not, namali ni siya, no? This is 0.24, not 0.25. Alright. Then, the movable partition, which is 0.5 kPa. Then, versus blown for gravity loading. For ceiling suspended channel na acoustic board, that is 0.15 kPa. And for EE plumbing utilities, that is 0.1 kPa. So that the total floor slab with ceiling and utilities, kung i-add nimo to siya, tuloy na naman siya, follow ninyo. Unang 0.196 on floor area. Then, the loading, katong gapalibot nga naapa may gapalibot nga CHB wall, no? This is times 3.3. Okay. To get the uniform load, no? Kilonewton per meter on beam supporting walls, that is 3.3 kani siya times F10 times 3.5, which is the height of the wall, no, from the floor beam to the upper beam. Then the loading of the interior walls. So this computation will be incorporated in your STAAD puhon if you're going to use STAAD as part of your modeling and analysis. You have to compute this computation of your dead load. So, ma-follow naman siya, no? Then, depende sa inyong building, depende sa inyong design, sa inyong buildings, then, you have to compute, no? Because, sa final, I'll have to check your computation, then, your building, then, your computation, then, your STAAD also. I'm going to check your STAAD kung sakto ba ang computation as well as sakto ba ang pagkaputang, no? So, I think last semester, no, we had already a seminar workshop on STAAD, so no need to no need to again do the workshop, no. So, muna siya. Then, for the slab, for the roof deck, no, because building has roof deck. So, muna siya actually. So, ma-follow na siya ninyo, no? Then, the total floor, no, slab load with ceiling utilities, I mean this one, is the summation of those slab, which is 100 millimeter thick. So, 40 floor finish, then ceiling and electrical and mechanical plumbing utilities din, or miscellaneous waterproofing. So, may siyang i-add nimo. Then, loading sa exterior walls, so, no, sa roof, na siya parapet. So, muna, 3.19. Where is 3.19? This HB wall nga, 100 millimeter times the 1 meter height nga parapet. This is the uniform load. Then, for the live load actually is, I've discussed this one, no, sa katong table na live load. Then, for offices, no, kung office ang inyong building, then you'll have 2.4 TPA. Then, the stair load. So, the stair load is 0.2. This is the thickness, no? 0.2, this is the thickness, times 0.56, this is the unit weight of the concrete. Cubic meter man siya. Times 5 meter. This is the kuan kanang this is the 5 meters. This is the katong horizontal distance of the stair, no? Kung padulong mo dito, for example, padulong mo dito, gaana ang stair. So, what is the distance gikan sa inyong first step to the katong one stair, ana, first step to the landing. So, man siyang 5. Then, you'll have to divide this one by 2 because mo siya ang load nga katong naman tayo gitawag nga stair beam, no? Mo ni siya nga load ang katong mo hold atong sa stair beam. So, dito i-apply nimo ang kuan katong this one nga gi-dividean og 2. Then, live load for stairs is 4.8 kilonewton per square meter, no? Times 5 divided by 2, no? Live load for stairs. So, yung lang. You have to compute your own, no? According to your building design and orientation, or design. Then, we have to discuss building weights. Building weights or seismic. Okay, I think we have to discuss kuan. The seismic, no? Seismic load. Okay, kani siya. This one, seismic. Maybe I'll continue to discuss na lang ani, no? Separate kuan for seismic. Then we'll discuss the kuan. Another computation of your building weights, seismic and wind load, no? Separate computation. Separate record.